Welcome to the explainer. Sometimes in manufacturing, a simple choice can have huge consequences. Today, we're diving into one of those, the diaphragm dilemma. It's this constant tug-of-war between saving a little money now and ensuring long-term safety down the road.
All right, let's jump right into the big question, one that every process engineer has to wrestle with. You've just finished passivating your system. Now what? Do you really need to replace all those valve diaphragms? On the surface, it seems like a straightforward yes or no, but trust me, it's way more complicated than that. And look, this isn't just about ticking a box on a maintenance checklist. We're talking about a decision that has a direct line to your product purity, to patient safety, and of course, to staying on the right side of GMP compliance. The stakes here, they're massive. Getting this wrong, well, it's not an option.
Okay, so to really get to the bottom of this dilemma, we've got to talk about passivation. It's a process that's meant to protect your system, but it comes with a hidden danger, a real catch-22.
So let's be clear, passivation at its core is a really good thing. I mean, you want to do it. You're basically giving your stainless steel system an acid bath to get rid of any stray iron and build up this super strong protective layer. The whole point is to stop corrosion in its tracks and keep your product absolutely pure.
But, and this is a huge but, here's where the plot thickens. That same process that's a lifesaver for your steel pipes, it can be a total nightmare for your diaphragms. You know, those little seals that are the unsung heroes of the whole operation? The very acids doing the protecting can actually eat away at the seals, making them porous. And once they're compromised, bam, you've got a wide open door for contamination. So this naturally brings us to the main event, the material showdown. Because let's face it, not all diaphragms are created equal, and your choice of material completely changes the game. Okay, so this really lays out the fundamental choice you have to make. In one corner, you've got EPDM. It's the common choice, it's cheaper to buy, but it has an Achilles heel. It's porous, and it just doesn't stand up well to harsh chemicals. In the other corner, you've got PTFE. You probably know it as Teflon. Yeah, it's gonna cost you more up front, but this stuff is a chemical fortress. It's tough, it's durable, and it's built to last. And when you actually put these materials to the test against the acids, the picture gets crystal clear. Look at EPDM. Sure, it can probably handle a gentler citric acid treatment, no problem. But throw some aggressive nitric acid at it? Whoa, that's a high-risk situation. Now look at PTFE. It just shrugs them both off. The risk is basically negligible. The choice really starts to make itself, doesn't it?
All right, so what's the takeaway here? It's that a simple always replace or never replace rule just doesn't cut it. We need to move beyond that and build a smarter, risk-based strategy that actually fits your specific setup.
And this is probably the most important principle of all. You have got to ditch the one-size-fits-all mindset. It just doesn't work. What we're talking about is creating a smart decision-making process that's grounded in the reality of how your system actually operates day in and day out. So how do you do that? Well, here's a really practical four-step way to think about it. First, look at your chemicals. Are you using the gentle stuff or the heavy hitter? Second, what's your material? Vulnerable EPDM or tough as nails PTFE? Third, and this is key, look at your own data. What does your system's history tell you? And finally, you wrap it all up by checking against industry standards like ASME BPE to make sure you're on solid ground.
We can also completely reframe how we think about this. Instead of seeing replacement as a chore, think of it as an opportunity. It's a golden ticket to get in there and really inspect your system. You can hunt for rouge, check if any materials are getting brittle. You can even use sacrificial diaphragms during commissioning to catch junk before it becomes a problem. It's your chance to be proactive and maybe even upgrade to something better.
Okay, let's wrap this up and boil it all down to the key takeaways you can put into practice on your very next project.
So, here are the 4 things to burn into your brain. Number 1, material is king. PTFE can often be reused, EPDM, not so much. Number 2, think risk, not rules. Let your specific chemicals and data be your guide. Number 3, replacement isn't a cost. It's a chance to inspect and prevent future headaches. And finally, number 4, there is no magic bullet. Always tailor your strategy. And that leaves us with one final question, and this one's for you. For those of you out there who've already made the leap from EPDM to something more robust like PTFE, what's the story? What does that return on investment actually look like for you? I'm talking real-world impacts on downtime, on safety, and on the bottom line. It's something to really think about.